So for those, you've seen the, you might have to scroll up to see the rules, but let's just keep this thing going. We haven't changed any of the rules. We want to make sure that this event is fast, factual, and fun. And so to get things started, we always start off with a cheers. So if you haven't got your beverage, we'll do a countdown here. So 5, 4, 3, 2, 1. Cheers, everybody.
Cheers.
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 All right.
Cheers. Cheers.
Monty, take it over.
All right. Somehow I got somebody else's screen there, but
Yeah.
We'll try to get that back. So this has been a tough year. We're all having a tough time. We're losing people we love. We're drowning in anxiety. So tonight, while we're here, while we're all together, let's consider just for a minute the upside of the coronavirus. Yes, the upside. The air is clear. Streets are quiet. We're reconnecting with the places we live and the people we love. And moreover, we're learning to work together to overcome a global threat that until quite recently, some of our neighbors denied was real. In other words, what we're doing today to survive this crisis will prepare us for what we need to do tomorrow to survive climate change. Now, I know that everyone on this call already understands how Passive House mitigates greenhouse gas emissions. Our task for all of us is to educate our 7 billion neighbors about how Passive House can help mitigate greenhouse gas emissions. And some of us think coronavirus actually might help us achieve this task. So for tonight, April Fool's Day, at least in my time zone, we've put together a list called 10 reasons the coronavirus crisis will mutate into a Passive House pandemic. And to present our top 10 list, we have a very special guest, Dr. Wolfgang Feist. Are you?
Everybody, speaking from the first Passive House in Darmstadt. Well, it's a late night show here. Really late night show, and I always wanted to be a comedian, and well, I'm going to be at this time.
All right. Without further ado, here are the 10 reasons the coronavirus crisis will mutate to a Passive House pandemic. Reason number 10.
The novel coronavirus has reduced greenhouse gas emissions up to 50%. Passive House can do more with far less costs, up to 90%.
Very good. Reason number 9.
Public health experts fret about insufficient testing and the lack of long-term scientific monitoring. We Passive House guys do exactly the same.
And reason number 8.
After months of feeling anxious, whenever someone coughs, the whole world is now thinking about air tightness.
True. Reason number 7.
After months trapped inside our apartments, where some of us can hear our neighbors and everyone, many of us will be longing for thicker walls.
Yes. Thicker walls, absolutely. Reason number 6.
After months without a date, billions of single people will be looking for thermal bridges.
I think that is absolutely true. Reason number 5.
Living in a Passive House is like social distancing. You can adjust the thermostat anytime you like, but you may have to wait for weeks and plot a graph to determine whether it made a difference.
That's quite true. Reason number 4.
The World Health Organization advises we postpone large gatherings until the fall. The International Passive House Association advises we host Passive House days in November.
True, and we will.
Perfect.
Reason number 3.
After all this talk about flattening the curve, politicians will finally understand the difference between peak load and annual demand. Well, I don't know.
Some politicians, maybe. And reason number 2.
They'll pretend.
High quality ventilation equipment is the appliance of the year.
True, there is a global demand. And finally, the number 1 reason why this crisis may lead to a passive house pandemic.
Just 2 words: hygiene criteria.
Absolutely.
Your hands.
All right. Well, there you have it, folks. Top 10 reasons the coronavirus crisis will mutate into a passive house pandemic.
Excellent, gentlemen. Thank you so much for joining us. Again, Dr. Feist, thanks for staying up so late to join us. It's fantastic. We always like to give attendees an opportunity to check out different announcements. So Zach, do you want to give us an update?
Yeah, absolutely. So first, thank you very much, Wolfgang Feist, for being here. And I wanted to let everyone know that we've got an interview that we just published on the Passive House Accelerator site with Wolfgang. So I encourage everyone to check that out. We just published that this morning. Also, we have a poll. We've got a little polling that we'd like to do. So I'm going to launch that now. But if you wouldn't mind filling out this question, and then I'll follow up with another one soon. That would be great. I talked about a bunch of event deadlines and stuff and events last week, so I'm not going to do that again today, but please visit the Passive House Accelerator events page to get information about what's coming up. And also, if you have an event that you'd like to share, please share it in the chat now. And that's a great way for us to be getting info out to one another. And I think with that, that's pretty much it. I'll share the link to the interview with Wolfgang now.
Perfect. Great stuff. Thanks, Zach. Thanks again, Passive Auxiliary, for helping us out to help with this. Let's get on to our feature presentation. Tim McDonald from Onion Flats, honestly, is someone we all need to aspire to be. He has figured out how to make passive houses affordable and seems to always add a touch of innovation to each project. One of his successes is that he gets the passive house standard into the DNA of the project. So he gets it into the owner's brief. So it becomes, again, a real intricate part of the project. And so I'll just say that again, if you want to make or break your construction budget, get the passive house standard into the owner's brief so that it starts from day one. So Tim is going to be showcasing a project that his son thinks is ugly. I think it's awesome. So again, they always say the beauty is in the eye of the beholder. Tim, thanks for offering to share your story, and take it away. We'll let you share your screen. And thank you so much for being here.
My pleasure. My pleasure. Hold on. Trying to get this screen up. Okay. And everybody seeing that?
Yes.
Yeah.
Okay.
Yep.
And we do good ugly.
Yeah.
You will see where that comes from. Okay, so
Ugly
this is what's that?
Ugly delicious.
Anyway, this is a 15-minute presentation, and so I'm going to move that. What was it? Fast, factual, and what?
Fun.
Yeah, we're going to have fun. So look, I am a developer, an architect, and a builder, and we also have a green roof company, the green roof and solar company called Grass. The project I'm going to show you is one of our own developments. Hold on. Okay. And here it is. It's in a gentrifying neighborhood in Philadelphia called Kensington, jammed up against the elevated train. Kind of a rough neighborhood. But it's also where our offices are, which is right across the street. We're moving our offices into this building, which you'll see in a minute, when we ever do choose to get back to person-to-person contact, although we're working so well from home, we're starting to reconsider whether we take over this office space. That's another discussion. So the gist of this project is it's a 28-unit apartment building with an office space on the ground floor. It's about 24,000 square feet. Here are the specs of the building. I'm not going to go into them other than to say, you'll see pretty quickly how the PV array becomes the real issue of this project. We've got 174 kW array wrapped around the entire project. This is what it looks like from the same perspective now. We built it for $180 a square foot, which in Philadelphia numbers is on par with what everyday code-built 80% less efficient buildings are being built for. I'm showing you the basement of this because I just want to point out one kind of site planning, pretty much the only site planning move we did, because it's on a very tight site with buildings on both the north and the south side, streets on the east and west side. We carved out the southern section of the building in order to have the office space in the basement actually walk out onto a terrace garden. Here's what it looks like on the first floor. We've got 4 apartments on the first floor and the lobby and the office space. But here's what that carve out looks like in section. This is looking at the south facade of the building. You'll notice the blue obviously are the solar panels. The windows are cut out of that solar panel screen, but you'll see this carve out that allows the basement to open up like this to the garden space. This is really, we just finished this in January. It's only half full, and of course that's all of that has stopped. We're not showing, it would be probably full by now, but we're not doing any showings at the moment. But this is the basement space at the bottom and the first floor at the top. This is what it looks like from the basement space. So why am I showing you this? Because it has something to do with, we set the building back 30 feet from the southern property line in order to really guarantee that if any buildings got built over the future, you know, in the future, we would still have that distance to allow light and energy to be generated from the southern facade. Here's what the office space is looking like now. We were supposed to move in today, actually, which isn't happening, of course. This is looking out over the courtyard. So I'm just trying to give you a kind of sense of the nature of the site. It's a very tight, very urban, rough and tumble neighborhood. This is a typical floor plan. These are micro units in our perspective, somewhere between 300 square feet and 500 square foot, 1 bedroom and studio apartment buildings, apartment units. And I want to focus on just showing you one design aspect. I could talk for a long time, but I just want to show you one design aspect of how we took on making these micro units macro. So how do you make something really small feel bigger than what it is? Well, what we noticed, one of the things we noticed right away was that the living kitchen area was really constrained by a typical bathroom. And so this is not passive house, but this is architecture too. So we thought it might be important to kind of rethink our typical understandings of 2 things. One, circulation space and bathroom space. So what if you could make a really thin bathroom that separated the toilet and sink from the shower, and then somehow, I hate hallway spaces because they're useless spaces other than getting from point A to point B, somehow incorporating the circulation space as part of that. And so I reached into my back pocket, and I love my favorite artist, of course, is Marcel Duchamp. I've always loved this work of his, which is a door that is always open and simultaneously always closed. And I thought, wow, I could be really literal here. And if the door, when it's closed in one direction, closes off the shower, and then leaves the circulation. By the way, this is actually the entrance into the apartment. Leaves the circulation alone, but when it's closed in the other direction, the circulation becomes part of the bathroom. So it closes the apartment off from the bathroom area. And so we're kind of using the circulation space in two ways. Just thought that might be fun to look. This is what it looks like when you're walking into the apartment. And we use a lot of translucent glass in order to use borrowed light coming from all directions to make these tiny spaces feel more than what they are. Next, because I'm just moving fast and factual and fun. This is the first time we've ever taken on a decentralized heating, cooling, and ventilation system, primarily because, unlike in Germany and other places in Europe, we don't have the magic box that we've been looking for forever that does heating, cooling, ventilation, and hot water. But Mutate, which is a Quebec company, has come out with a product that does 3 of those 4 things: ventilation, heating, cooling, as well as dehumidification. And it's similar to a VTAC and a PTAC in that the condenser is built into the unit itself, so there are no condensers on the roofs, there are no line sets to be run. And we thought we'd give it a shot. We did a ton of research on it, did some engineering to see just how you model it, because it's a challenging thing to model. And so we located the unit on the outside of the outside walls, as close as we could, right up against the outside wall. And one of the other things that I really have hated about doing multifamily buildings is that I want to reduce the mechanical equipment, not increase the mechanical equipment. And with a lot of the early passive house projects I've worked on, the mechanical equipment gets doubled rather than cut in half. So one of the things that I hated was the idea that the hallway spaces, the community spaces needed a completely separate heating, cooling, and ventilation system. So this Mutate unit can handle up to about a 1,200 square foot house, actually, in terms of heating, cooling, and ventilation. So we just thought, why not supply ventilation, heating, and cooling from one of the units with a fire damper in the wall, and then exhaust from another one in order to eliminate any need to condition or ventilate the shared space, the common area, with a separate heating, cooling, and ventilation system. So that's what we did. And so, again, it's only half full right now, but it seems to be working well. This is what it looks like in diagram in terms of the piping. It's very simple. There's a supply, exhaust, and then supply and exhaust to different rooms. Very simple piping diagram. Here's what it looks like in practice. Now, what I will say is in 450 square feet, that takes up a lot of space, but we turned it into kind of an addition to the kitchen. So we turned it into a piece of cabinetry. If you can see, these are drawers on the bottom, and then these are cabinet doors. You can kind of see it here as well on the right-hand side. It kind of blends into the kitchen area. It does take up a lot of space, but we were able to make something out of it. Here are some of those units. This is a unit where the bedroom has bifold doors that close it off. On the interior, opens up into a kind of loft-like apartment area. And what I want to start to talk about now is the thing that everybody's been talking about, how ugly or beautiful it is. It's the facade itself. And you can see through these windows that the PV panels are actually kind of cropping up into the area of the window, like pretty significantly. And we did it, I'll say this, that the dimension, we're working with what we've got. We've got certain dimensions and proportions of windows. We've got certain dimensions and proportions of PV panels, and they're kind of unrelenting, and they don't allow us to do anything we want. But I kind of like the juxtaposition of the skin that is overlapping with the windows, because they're floating away by about 24 inches away from the facade. It's kind of a messy facade, but that allows you to open windows. But more importantly, I'll say this, notice, have you ever, those of you who don't know what bifacial panels are, notice there's no frame, no aluminum frame, and the backing is translucent. So these panels are actually, look at the light that's coming through these panels. So it's more of a veil than it is a solid block. So even when you're in these apartments, the light is just, there's plenty of light in the apartments. And really the function of this, what I call the solar veil, is three things. It's not just about generating power. By the way, bifacial panels generate from both directions, because the cell actually generates energy from the back as well as the front. But that's only the first one. The second one is that it's very intentionally a shading device in the summer. So it keeps the summer energy out of the building, but allows it in the wintertime. And but the other thing that it is in this really tight urban footprint, it's also a visual privacy device. And so you can jump around in your underwear with your friends and lovers and family and not need shades. Here's one of those 300 square foot studio spaces, no bedroom. This is a Murphy bed that folds down and then closes up. Obviously entertainment system and storage. This is what it's looking like in the other direction. And then quickly to hot water. We initially thought, because I had done a centralized hot water system on our last multifamily project, and I wanted to rethink it because two things. So let me just quickly, we thought Sandon would be a great opportunity, but then when we dug into it, we realized that the distance between the tanks and the heat pumps on the outside, and the heat pumps would have to be on the roof for our project because there was no space outside. All of the tanks of water would have to be on the 4th floor. That was one problem. The second problem was that I really wanted to try to radically reduce the recirc loop associated with hot water, because once it's easy to get the heating and cooling radically down. It's hot water in a multifamily project that really takes over after that. And so this recirc loop, hundreds and hundreds of feet of piping, insulation, heat loss because of all that piping, the cost associated with the energy, call it penalty associated with it, just to have hot water come out immediately from your tank with that recirc loop, it was just too much. And so I long story short, worked with the hot water guru of North America to come up with a decentralized plan that kind of worked with, if you can imagine the sewage lines going up, the stacks going up through a multifamily project. If you follow those stacks carefully, the intention of those stacks is to very quickly tap into, with very short horizontal runs, tap into the bathrooms and kitchens off of that. And so we broke this up into 4 stacks of 2 typical heat pump water heaters. It ended up being half the price. We ended up using half as much piping and therefore insulation and therefore heat loss. We were able to locate them all in the basement. And here's where those stacks come up between the the bathrooms and the kitchens with very short horizontal runs. But the other thing that just made it even more exciting for me, and I gotta say, this is one of the things I just talk about all the time, is this pipe and pipe technology that we discovered. Now, what the hell is this? Imagine the stack of your hot water, so your supply for hot water coming up in one shot, so just up 40, 50 feet, very short runs horizontally, but then typically your recirc loop would then have to be a completely separate line that came down and tied into a pump that kept that flow going. Well, this technology puts the recirc loop actually inside the supply line. And I had to do this drawing in order for you guys to understand, because it's hard to understand. Here's the supply line, the hot water supply line. Here's the water heater. It's supplying hot water. It goes up, feeds the first floor, second floor, third floor, fourth floor. And typically then it would then turn around and we'd have a totally separate line coming back, insulated, everything. This goes inside the pipe. So, and the way it works is, if you can see this up here, there are just these holes in this fitting. It's two fittings, one fitting, two fitting at the top and bottom. You put this PVC pipe inside the copper pipe and you insulate one pipe. I mean, it's so dumb, it's brilliant. And that fits with our good ugly thing. And here's what it looks like. Two typical heat pump water heaters working together. It's been working fine. Again, we're half full, but I think we have the right amount of storage here, and it should be fine. Another real quick note, and I'm not going to talk about this, but you can ask me questions. We have one meter. We made this decision a couple of years ago. We're not going to have individual meters per apartment, given the fact that, you know, the charges would be almost nothing for each apartment. So it saved us space, it saved us money, and we're still able to monitor every apartment with CTs on the apartment feeds. And then just some images of this is the foundation being built. You can see how close we are to the elevated train, about 12 feet away from the elevated train. This is a very urban situation. We were up against a building. That spray foam is actually sealing the existing building on the side. We were concerned about getting about this adiabatic wall not really being an adiabatic wall, because that building is abandoned on the other side. So we just sealed it off. We built this with Build Smart panelized system, where the windows and doors are already installed, rigid insulation's already installed. Went up very quickly in about 5 weeks. This is it. This is the roof. As you can see, we're building the roof is an occupiable roof, which you'll see in a minute. This is the first time that we didn't hit the blower door test. It's a super tight building at 0.79 ACH 50, but I started, you know, I think you win some and you lose some. We made a couple of decisions. One was we took the office out of the thermal envelope, technically, although it's still got balanced ventilation, it's still got really good glazing, but it's a lot of glazing. If this would have had to have been triple paint, we just wouldn't have been able to afford it. But we also took the basement out of the thermal envelope. And this is the first time we've ever done a decentralized heating, cooling, ventilation system. So we've got 56 penetrations in the walls instead of 2. So, you know, I'm still fine with the decisions that we made, but I think that's where, for instance, what we discovered was some pretty significant leakage between the stairs that came down into the basement area that is not part of the thermal envelope. So here it is. It looks really ominous, and scary to some. This is during construction. We're not complete there. But you can see how dense of a community we're dealing with. And the other thing is, you know, this is a pretty loud train right here, right? So the passive house envelope really helps with that. People don't even know that you're right up against the train. And the roof seems incredibly, you know, closed off and opaque, but because of these solar panels, they bring enough light and water and air, obviously. This will be a green roof in the summer. We haven't planted it yet. But it's also just a really wonderful space to hang out in, because the summer's will allow for people to hang out and grow their tomatoes and basil in comfort. It's designed to generate about 20% more than the building needs. And here are just some images of those juxtapositions of the city. And the light passing through, you can see the kind of lines of light passing through the building, the panels on the before it was finished, up against the, it's even difficult to get. Oh, and this is our entrance. My friend has these modular moss walls that has water spraying and light built into. It's just a beautiful entrance into the building. And then I'm just going to leave you with this. This was I think this was mentioned in the announcement to this. There's this really great article done by Inga Saffron on this project, and she was critical in a very constructive way, and it was very much about, I mean, you can just read this stuff, but I loved her comment about how this is maybe if this is the future of architecture. I don't agree with this, but maybe if this is the future of architecture, we have to rethink conventional ideas about beauty and comfort. But the comments that got created from this article were incredible, and I can't read Paul Goldberger's over there because some people are, the images are in the way. But I loved what he said. He said something to the effect of, it's not about whether this building is good or not. It's really about, does it make us rethink what is ugly? And my favorite of all, which ties back to the title, is this guy who lives around the corner. I lived near this and thought, damn, it's ugly. The difference, though, from all the other new, I would say, ugly construction, is that this ugly is good ugly. Impressed and glad to read this after walking past it for a while. So that's what I'll leave you with, other than this. You guys, if nobody knows about this conference, please come. It is an awesome conference that we started with Green Building United, this amazing organization, Philadelphia, about 4 or 5 years ago. And it is specifically focused on affordable housing and passive house. And this year, it's been in Philadelphia every year for the past four years. This year, we moved it to Chicago because we're working with Illinois Green. And Ed Mazria, please, if you don't know who he is, look him up, the founder of Architecture 2030 and so many other things. He's going to be our keynote speaker. So I'll leave it at that. Thank you.